Hello everyone, welcome back to another lesson with CS with Mr. G. In this lesson we're going to look at input devices. This is part of the hardware unit, unit 3, and today we will look at this term input, where we will look at which devices in particular input data into a computer and discover the basics of how they work. The syllabus does require us to know the different types of input devices, why they are required, and a little bit of how they work. The devices that we're going to look at are listed here, and we'll go through each one, looking at the basic workings and why these are used in today's world. So first and foremost, something I teach my younger students is when it comes to identifying if a device is an input or an output, you need to forget about the wires. So if it has a wire going into a computer, if it's got a USB connector, or even an optical disc, as these are not input devices. All these devices you can see at the bottom here, these will all have a wire or some kind of connection to a computer, whether it's wireless or with a USB connector. But the point I'm trying to make is that despite the wire is plugging into the computer, that does not determine whether it's an input or an output device. What determines an input device is that data is transferred into the computer. Okay, you need to think, is data going into the computer or is it coming out? And what this data typically is data that we can typically understand in the real world. So if you think about my voice now, I'm recording my voice via a microphone, and that data is going into the computer and being stored on my device. So that's what differentiates an input from an output device, whether the data is going in or out of the computer. And that's very important. I've seen very silly mistakes made in exams where students can get this mixed up. And like I said, this is something I often teach to my younger students, just to get those basics in there so that we can understand how these devices work on a more technical level. So as I've said, any hardware that inputs information and converts it so the computer can use it would be classed as an input device. Remember, the data that it's being converted into is binary. Everything that the computer knows and sees and understands is all in binary. Okay, very important. So the devices along the bottom we'll go through, starting with two of the most easiest to understand, and this is the keyboard and mouse. So when it comes to identifying an input device, these are typically the first two that spring to my mind. And all we have to think of is what's going on when we press a key on a keyboard. And like I've said, data is being sent from the keyboard into the computer. And what the data is in this scenario is just a binary number, and this binary number represents a letter. If we think back to Unit 1 and the ASCII table and Unicode, all letters and symbols have a binary number, and when you press the keyboard key, this binary number is sent down the wire or through a Bluetooth connection, and that character or symbol is displayed on your screen. When it comes to a mouse, as we know, a mouse has an optical light at the bottom. We put it onto a surface, and as we move the mouse around, a sensor will detect that and the pointer will change position on the screen. So very simple. You don't have to go into too much detail about describing these devices, but again, keyboard and mouse, the most obvious of the input devices. Next we have microphone, and a microphone obviously converts data from sound, so capturing sound waves and converting this into a binary number. All of this has been discussed in Unit 1, but a microphone is the input device which captures sound waves and converts it into binary and into a digital format so it can be used on a computer, whether it's a voice, whether it's a song, whether it's music. Microphones are typically built in these days, so you don't even have to buy them, and it's typically a small hole on the side of a device which picks up the sound and converts it into digital. Of course, you can buy external microphones for much better quality. These can be connected via cable or even wirelessly via Bluetooth, which then allows us to use this audio on the computer in a digital format. If we think back to Unit 1, we do have to show a bit of knowledge about the process that takes place here, and mentioning words like analog and digital is crucial. If you were ever asked to describe a microphone or to list an input device and explain how it works, using words like analog and digital again would be crucial, and you could mention that a microphone converts analog data into a digital signal so a computer can understand. So ADC is the term, analog to digital conversion, and this takes place amongst most input devices, especially when it comes to sensors, which we'll look at in a later lesson. Next we have touchscreens, and with touchscreens we have to be careful here because touchscreens are classed as both input and output devices. The reason being is that a screen or a monitor would be classed as an output device. However, a touchscreen takes the input of your finger and also shows you the display. So we have to be careful. The touchscreen can be classed as both. Now, why I've put it in the input devices lesson is that there are three ways we input information using 3 different types of touchscreens. Okay, and we have to show a knowledge of these 3 types, although you will probably only ever have used one in your lifetime. Okay, so these 3 types, you've got resistive, capacitive, and infrared. And the one that you will have used, or probably using right now, is a capacitive touchscreen. Any touchscreen made in the last 10-15 years typically uses a capacitive touchscreen, okay, stemming from iPhones to modern tablets. Most touchscreens nowadays will have a capacitive touchscreen. And the way you know it's capacitive is that if you wear a glove, it wouldn't work. So if you put a glove on and your finger doesn't work on the screen, you know for sure you are using a capacitive touchscreen. And the reason for this is because it behaves just like a capacitor. It's reacting to the stored electrical energy in your finger. Okay, the static electricity in your finger is picked up by the screen, and that's where the phone or tablet can react or open an app you've pressed on, or simply do whatever it is that you're trying to do based on this stored electrical energy. As we know, we can touch a capacitive touchscreen in more than one place. So you can have multi-touch. So you can have 2 fingers touching it. For example, if you pinch and zoom on a tablet, that's using 2 fingers. And again, this is crucial because it's a capacitive touchscreen. And there's 2 layers. You've got the input layer, the touchscreen, which you touch, and the display underneath, which is what you can see with your eyes. And again, if you're wearing a glove and your screen doesn't work, then you know for sure you're using a capacitive touchscreen. Okay, just some notes there. They have a smooth surface, very easy to use and press, and they are very, very accurate. Like I've said, you can't wear gloves, although you can buy special gloves which allow electricity to pass through the finger. And if you think about it, this is the reason why you can't use any object to control a touchscreen on your device. You can't just pick up a random pen. You have to buy a special pen, such as an Apple pen, which again will allow for an electric current to pass through the tip, but as I've said, offers high accuracy and are very easy to use. The second type is resistive. Now, resistive touchscreen aren't as popular anymore. And the only real example I can think of where you might have seen one is maybe in your school if it's got a smart board or a large display that you can control with your finger. But resistive touchscreens work in a completely different way to a capacitive touchscreen, as they literally just respond to anything touching it. Okay, you can literally grab any object and can touch the screen with it and control it that way. Okay, the reason being is that it has 2 layers, as you can see here. And as these layers are physically pressed and touch each other, the device will respond and know whereabouts it's being touched on the screen. Okay, so the key to a resistive touchscreen is the 2 layers, the gap in the middle, and when the 2 layers touch, the device knows it's being pressed. The last one is an infrared touchscreen. This is where an infrared light is shone across the screen from edge to edge, and when this infrared light is blocked, the device can determine whereabouts the finger or object has blocked the light, and that will determine the coordinates, or basically where you've pressed on the screen. So similar to a resistive touchscreen, as it only has one coordinate that it can calculate, but it uses infrared lights to determine this, as your finger or object will block the light, and that's when the device will know whereabouts you've pressed. Next on our list of input devices is a 2D scanner. And these are literally used to convert a document or a photograph into a digital format. Again, remember, this is binary, and a scanner literally takes in a document or a photograph and converts it into a digital image on your computer. On a technical level, once the lid is closed, a bright light scans across to make sure it picks up the pixels and their colours, and these pixels and colours are then converted into binary. Now, there's a good chance you might not have seen one that looks like this because they are typically built into printers, and they come as one big device now, although a printer is technically classed as an output device, so we have to separate them as a scanner and the printer rather than the whole device together. Okay, so the scanner itself is an input device, as well as a 3D scanner, which takes in the input of a 3-dimensional object as opposed to a 2-dimensional, using the X, Y, and Z axis. So 3 dimensions of an object are scanned. It typically uses infrared lights and can be used in many different ways. You might have seen video games being made with 3D scanners. CAD/CAM projects or products being designed on a computer can typically use a 3D scanner. And they can also be used in conjunction with a 3D printer, which is an output device and will be discussed in the next lesson. Next, we have a barcode reader, which works in a very similar way to a 2D scanner in that it uses light. But a barcode reader is typically used to detect the barcodes on products, or these black lines you can see here. These black lines return a value or a series of digits, and these digits represent a product or an item, so it can be used in a shop or typically anywhere that stores details about items. If we think back to Unit 2 and we look at this term check digit, barcode readers use a check digit to make sure that the numbers have been scanned correctly. Otherwise, an error would occur and you would have to rescan the item with the barcode reader. So as you probably know, these are used in shops, supermarkets. You will have seen one of these in your life somewhere, And typically in self-service checkouts now, you have to use them yourself. But with the barcode reader, it scans products very fast. It saves time and effort having to type numbers in. And again, if you think to a supermarket and items being scanned across a barcode reader, it's very fast and efficient. When the barcode scans those black lines, it returns a number, and this number identifies a product. Again, it saves time as it will return a price for that item. It can also determine how many of that item is in stock. And another huge advantage is that by having barcodes on products, if any details were to change about the product, you wouldn't have to change the barcode on each product. You would literally just update your system, or the shop would update their system, so the identification for that product would simply just change price or details, and you wouldn't need to change the barcode on every single product. And as I've just mentioned, self-scan or self-service tills, customers can now scan their own items using barcode readers. Now a QR code reader, I've put here that it works in the same way as a barcode scanner, in that it's a device that scans a type of code. However, QR codes don't typically have a specific device. If you think about it, it's literally your phone or some kind of camera that detects a QR code. So a mistake that I've seen students make is that they refer to a QR code scanner as a device itself, whereas the device that you want to be talking about is the camera in a smartphone. This is what picks up a QR code. Now, where it differs to a barcode is that a barcode typically stores around 30 numerical values. A QR code can store 7,000. Hence why QR codes are used for things like hyperlinks, taking you to a menu of a restaurant, or even a boarding pass on a flight or a train. So having this extra information being able to be stored is super useful, especially in today's world. You've got things like tracking packages, restaurant menus, concert tickets, business cards, just information in general on a poster, and like I've said, even a boarding pass for a flight. Now, there are many different versions of QR codes, and when I'm talking about versions, I'm talking about the squares involved in the actual QR code itself. So if we just zoom in here, the amount of squares on the grid obviously will increase over time. Okay, the current version I think has about 177 squares this way and this way, which obviously allows for a lot of different patterns. But what's really useful about QR codes is that these 3 squares around the edge, they determine which way round the QR code should be. So basically you could scan the QR code from any angle, whether it be upside down or to the left, but these 3 squares around the edge will tell the device which way round the QR code is. So very useful. You can scan them from quite far away, especially with smartphones having really high quality cameras nowadays. But like I've said, they typically take you to a website using a hyperlink, or are used in any of these scenarios here. And finally, we have a camera. So a digital camera or even a webcam. I'll just get that in there. Webcam can be classed as a digital camera, or a smartphone camera will be classed as the same thing. And these use what we call a CCD sensor, a charge coupled device, which allows the camera to pick up what it can see in front of it and convert that into your grid of pixels, which can then be converted into binary numbers. So this sensor that I'm talking about measures the light intensity of each pixel, and that pixel is stored as a number, which each number equals a color. As we know, this information is all stored on the camera's memory card or even your smartphone's internal storage. And as you can see here, once a camera sees something in front of it, it will break it up into this grid and can convert this information into pixels, which can then be stored as binary. Obviously, this is a very simplistic version, and cameras do not take photos like this. And that is all of the input devices that we need to know, guys. Okay, so a very simple lesson. The next lesson that follows is obviously output devices, which again is a very easy to understand topic, but we just need to cover the basics and go through some examples of devices and where they are used. So hopefully I will see you there, and I hope you've enjoyed the video.